All right, so guys, let's go on and get started. The notes that I passed out to y'all are chapter 6 notes. So we're going to, the two topics we're going to cover today, guys. We're going to do 6.1 and 6.2. So we're going to talk about confidence intervals for the mean. We're going to talk about estimating population parameters, things like that nature, okay? So I want to try to explain this to you in the easiest way possible. Y'all ever go like anybody here eat like fruit? You like fruit's like one of your things to eat. You like fruit a whole lot. Okay, what's the fruit that's probably in season right now? Oranges, right? Okay, so say oranges, or let's talk about summertime, right? Watermelons is very popular in summertime. Okay, so guys, if we said something like, say we went to like some kind of market or somebody on the side of the road, somebody has a pickup truck, right? They got a whole bunch of watermelons in there. And we said that the average weight of those watermelons, I'm going to make this up, is like, I don't know, say 13 pounds, something like that. Have you ever heard somebody say, man, I'm confident, I'm like 99% sure that I did this. I'm 99% sure that I signed my name on the check when I sent it in. You've heard that kind of expression before, right? Okay. So that's one of the things we're going to be talking about today. So we said, look, you know what? We went to this truck, we found the average weight of the watermelons. So we weighed all the watermelons on that guy's truck. We found the average weight, right? We added them all up, divided by however many we had. Then we could say, like an expression like, I'm 95% sure that if we were to go pick any watermelon in the field where this guy got his watermelons, that they would be about 13 pounds plus or minus, half a pound or something like that. You've heard that kind of expression before. Okay, so guys, that's what we're basically going to be talking about today. So, confidence intervals for the mean. Let me see if I can pull this up real quick. Let me see here. Let me see if I got it here. Where's my test one? Should be somewhere here. Here we go. I want to see if it pulls it up. Okay. So guys, do you remember when this was the formula sheet we used on test one? So remember, guys, when we talked about population mean, we used the letter mu, right? And when we talked about sample mean, we used the letter x bar. And then when we were doing our standard deviation, we were using the calculator, and we would come up, it was that whole list. Once we did the one variable stats, we would come up with two standard deviations. One had the little sigma, and do you remember the other one had the little s for the sample standard deviation? Okay, so today, guys, one of the things that we're going to be talking about, we're going to be trying to sort of estimate what the mu would be, right? The population, so all the watermelons, knowing a particular sample of averages, and we're going to be using the population standard deviation, okay? So I'm going to come back over here, and it says a point estimate is a single value estimate for a population parameter. The most unbiased point estimate of the population mean, mu, is what we call the sample mean. So again, we talked about two different means before. We had the sample mean, we had the population mean, okay? So we're going to estimate the population average using a sample statistic, okay? So let's take a look here. It says the data below represents a random sample of number of hours worked by 30 employees from several grocery stores in a county. Find a point estimate for the population mean mu. So guys, what I'm going to do here, I'm going to grab my calculator. Let's see, there we go. Let's get this guy running. Okay, I'm going to turn it on. I'm going to clear it. I'm going to go to stat. And guys, I'm going to edit my first list. Okay, so I don't have anything in my list. What I want to do, I want to enter all those numbers in there, okay? So look, I'm going to go 26. And there's 30 numbers, so it's going to take me a little while to do it. Yes, ma'am. Question? Yeah, it should be recording. Yeah, we're good. Yeah. So guys, look, I'm going to just start entering all my numbers in. I want y'all to do the same for me because a big part of it is going to be, do you understand? Are you kind of following along here? So 32, 46. Guys, if you need to grab a calculator, come on up and pick one up, okay? 32, 25, 22, 22 again, 20, 36, 32, 28, 25, 35, 38, let's see, what, 31? 31, 25, 22, 22 again, 32, let's see, 28, 21, 26, 32, 22, 28, 40, 24, 48, and one more is 19. Okay, so guys, we got all of our 30 numbers in, right? Then what I'm going to do, I'm going to come back to stat, right? And I'm going to go to calc, and we're going to calculate our one variable stats, right? For which list? List 1, right? Guys, you know how in your calculator you have a frequency one, and usually it says L2? Make sure there's nothing there, so you can just hit delete or something, but you don't want to have anything on the frequency, okay? You shouldn't be anything there at all, okay? And let's go ahead and enter it. Okay, so my question to you, what is the sample mean? And again, guys, just to kind of give you a heads up again, I'm going to pull up this piece right here. Remember what we're calling the sample mean? What's the little letter we use for the sample mean? X with a little bar on it, right? Okay, so let's just make sure we understand. And I'm going to come back over here. Did you get the same number for your sample mean? Did everybody come up with 28.9? Okay, so guys, just to like make a quick note here, Fred, you said you came up with 20 what? 28.3. Okay, so guys, if you're not coming up with 28.9, all it means is that when we enter those 30 numbers in, there's a mistake somewhere in entering those 30 numbers in. Okay, so the one thing I really want to mention is when you're doing that, be real careful, right? One small mistake will throw the whole thing off. Okay, but we came up with 28.9, right? So right here, guys, I'm going to go X bar is 28.9, okay? So it says, in the previous example, the probability that the population mean is exactly, in this case, 28.9, is virtually zero, right? So if you look what we're looking at here, we're talking about people who work in several grocery stores in a particular county, right? So like we're in Hidalgo County, we picked 30 people who work in grocery stores. Guys, do y'all agree Hidalgo County is a pretty big county? If you go as far west, do you know where the Hidalgo County line ends and the Starr County line begins? Sullivan City, right? So you got to go past La Jolla, right? You still got to go another 8 miles. Then you got to go through Sullivan City. If you ever go through Sullivan City and you're going past the speed limit, they will pull you over, okay? So go slow through there. And then when you get to the end of Sullivan City, there's a line that says, there's a sign that says leaving Hidalgo County, entering Starr County. Okay, as far east, if you were to get on the expressway and you were to start heading east, do y'all know where the Hidalgo County, Cameron County line is? Right there at Mercedes and La Feria, right? If you're in Mercedes, you're in Hidalgo County. You take 2 steps over and you're in La Feria, you're now in Cameron County, okay? Now we know as far south, but as far south as we hit the river, right? As far north, over the past San Manuel, right? So it's a big county, right? So look what we're looking at here. We're taking, say, all of Hidalgo County. Obviously, that's a massive county. There's a ton of grocery stores in Hidalgo County. What we did is we picked 30 people and we said, how many hours do you normally work in a given week or given whatever time? I'm guessing it's going to be a week here. And out of those, when we found the average for those 30 people, we said the average was 28.9. So what this is saying is, suppose we were to take the population mean, we were to find every employee for every grocery store in Hidalgo County. What's the likelihood that it's going to be 28.9? It says the likelihood is going to be what? Virtually zero, right? Because we have so many employees. You have some that work full-time, some that work part-time, right? It says instead, however, we can say with a certain level of confidence that the population mean lies within a particular interval. Oh, it's going to be 28.9 plus or minus so many hours, okay? So the level of confidence C, guys, is a probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times, okay? So I'm going to kind of show you what I'm doing here. It says the level of confidence C is the area under the standard normal curve. So this is when we were using our Z table or we were using the, like the normal CDF, that kind of thing, or the inverse norm. Between the critical values of negative z and positive z, the area remaining is 1 minus z. So remember, guys, if I'm telling you that the area here in the middle, I'm going to make this up. Suppose that area is, let's say, 80%. So it'd be 80%. What's the area under the total curve? It's 1, right? 1 is the same thing as, what, 100%? Okay, so if the area here in the middle was 80%, then that means that the area here and the area here would have to be the other 20%. But because this graph is symmetrical, it's telling me, look, if I have 20% left over, wouldn't that area be 10%? And wouldn't that area be 10%? Okay, that's essentially what we're doing. Guys, we're going to use these critical values in a little bit. I'm going to show you what happens if the interval or the confidence level is not 0.80, 0.90, 0.95, or 0.99, but those are going to be sort of standard numbers that we'll be using, okay? So if you do me a favor and turn your notes over to the next page, it says here, find the critical value, ZC, necessary to form a confidence interval at the level of confidence shown below. Okay, so guys, the first thing I want to do, I'm going to draw my basic normal curve like this, okay? So think about here in the middle. Y'all agree in the middle that my z value is 0, right? Because my average is always going to be 0 at that point. Okay, they're telling me that the c value, the confidence level, is going to be 92%. What that means, guys, is I'm going to put a little line right here, and I'm going to put a little line right here. Let me do it in red just so you can see a little bit better. Okay? Now, this value here is going to be a negative value, negative ZC. And this value here is going to be a positive value, positive ZC. All it's telling me is that the area here in the middle is going to be 0.92 or 92%. Okay? Guys, didn't we say that the area in total is 100%, right? 1? So look, if the area here in the middle is 92%, how much would I have left over for those two pieces? So it would have 0.8, right? Or 8%, or 0.08, I'm sorry, for each of them, right? Well, look, guys, if there's two parts, and the area left for each of them is 0.08, if we divide that by 2, do y'all agree that each one is going to be 0.04? Okay, so that's just telling me that the area right here is 0.04, and the area right here is 0.04, okay? Guys, on the test that we just took, the test you just took on Thursday night, one of the problems says, hey, look, if I know what the area is right here, I know I'm coloring it up, so I'm going to put the little 0.04 right here. If I know what the area is to the left, could I find the z value that tells me that the area to the left would be 0.04? Okay, so remember what we're going to do. We're going to grab our calculator. Okay. I'm going to turn it on. Let me clear this out. And I'm going to go second, bars. I'm going to go to inverse norm. Okay. What's the area to the left? So we're going to go 0.04. Okay. Close it off. And negative 1.75. Okay. So that's telling me right here, guys, that this number here is a negative 1.75. That's right. Right? So then wouldn't this one here be a positive 1.75? Okay, so look what it's asking me. It's asking me, can we find that critical value ZC? Here's my ZC, guys. So I'm going to go like this, Z, and I'm going to put a little, what was the C number that they gave me? 0.92, right? So I'm going to go like this. 0.92 is equal to, oops, 1.75. Well, think about it this way. Remember, since I'm looking for the positive, because it says find the critical value ZC, I'm looking for that one right there. Okay? All it's telling me, though, is that between negative 1.75 and 1.75, the area inside there would be how much? 92%, right? So if we know, again, guys, if we know that the area in the middle is 92%, that told me that this area was 0.04 and that area was 0.04, right? Oh, this, I'm sorry, it's supposed to be a Z. Sorry, let me rewrite that because it got a little messy. Like this. So Z of 0.92, because see how it says Z with a little C right here? And wasn't our C number 0.92? So I just put the 0.92 right there, right? I lost you?
No,
Oh.
it's because I got into the list and I couldn't get out.
Oh. Okay, so don't worry, we're going to do a couple more, okay? We're going to do a couple more. All right, so guys, this is how we find that critical value ZC, okay? So remember, and I'm going to be doing a bunch of problems with this, guys, and every one of the problems that I'm going to do, I'm going to draw the same picture every single time, okay? They're going to give me the confidence interval, and I'm going to have to find the Z values for that. That's right. That's right. Divided by 2. Because yeah, think about it this way. We're looking at the part in the middle, Fred. So don't I have those two areas? So remember, if the whole thing is 100%, think about it this way. If the middle was 90%, that means I still have 10% for each of those two. That means each one would be 5, right? Good. Okay, so 1.75. That's my critical value ZC. And I'm going to be doing a bunch of these here, Myra, for us to kind of... Right, ZC, right? Because if you notice right here, the part that I circled, it says, let's find the value for ZC. And all I did was because they told me that C was 92 or 0.92, I just wrote it as Z point, like with the little subscript 0.92, just so that I know it's for a 92% confidence interval, okay? All right, so guys, the next part here says, given the level of confidence, C, the margin of error, sometimes called the maximum error, or that error tolerance, is the greatest possible distance between the point estimate and the value of the parameter it's estimating. Let's see, it gives me some more info right here. It says, for the population mean mu, where sigma is known. Guys, I just want to make sure that we understand what sigma stands for again. So I'm going to come back over here, and I'm going to pull up my, my formula sheet. Do you see where sigma is right here? But which standard deviation? Is it the population or is it the standard? Or the sample, I'm sorry, it's the population standard deviation, right? So guys, what we're doing here is we're going to be given the sample mean, and we're going to try to see, can we estimate what the population mean would be, right? So if I know the average weight of 30 watermelons, could I at least have an idea of how much all watermelons would weigh, right? Within a certain range. So what I'm going to do, I'm going to come back over here, and it gives me a little bit of information, and I'm going to write this part down in a minute so I can figure out what I need to do here. So here's my margin of error E, okay? So I'm going to write this part down in the next step here, and it says we can use these when the conditions are met. Number one, the sample is going to have to be random, okay? And the sample is going to be normally distributed, or we have to have at least 30 items that we're looking at, okay? So let's take a look at problem number 2. It says, use the data in problem number 1 and the 95% confidence level to find the margin of error for the mean number of hours worked by grocery store employees. Assume the population standard deviation is 7.9. Okay, so guys, let me show you how I'm going to do this problem. First thing I'm going to do here, we're going to find a 95% confidence interval level. So guys, I'm just going to kind of shift this over a little bit because I want to draw my picture over here. Okay. Okay. And what we're going to find, guys, we're going to find our critical values. Okay. I know that I want the area in the middle to be what percent? 95%. So look, I'm going to go like this. 0.95. Guys, if you have 100% and you take away 95%, how much are you left with? 5%, right? Guys, as a decimal, does everybody agree that 5% would be written like this? Okay, now we have 5% to be placed in here and in there. So I'm going to figure out how much would each one have. 0.025, okay? So that means that the area inside here is 0.025 and the area inside here is 0.025. So what I want to do is I want to find what this value ZC would be, okay? So guys, remember the way I'm going to do this. I'm going to grab my calculator again, okay? I'm going to turn it on. Let me move it over a little bit so we can see everything. Okay, what is the area to the left of here? But hold on, but what's the area though on the inside? 0.025, right? So guys, I'm going to go second vars I'm gonna go to inverse norm, and we're gonna type in 0.025, right? Okay, I'm gonna enter that in. So remember, guys, with my z values, I'm always gonna use 2 decimal places. So the negative one here, would it be negative 1.95 or 1.96? Okay, so right here, this is gonna be a negative 1.96. And then this one over here, y'all agree would just be the positive 1.96? Okay. So the next thing I'm gonna do, are we good so far when we got to that pit point? Everybody following along so far? Okay. So guys, the next thing I'm gonna do, I'm gonna write down my formula right here. This formula, I'm gonna copy down. I'm not actually gonna copy every single piece of it. I'm gonna copy the part that I think is gonna make it easy for us to use. Okay. So if you notice, I kind of just sort of skipped this part here because the ZC is still there, but this little sigma with the X, the way I find that is by doing that part. So I just wrote it here for us. Okay. So guys, let me ask you a question. Do we know what our ZC value is? Did we find that already? Okay, 1.96. Okay. Times. Look, the next part, it has a sigma. Remember what sigma stands for? Sigma stands for the population standard deviation, right? What's that number for us here? 7.9, okay. Now the next thing is the N. The N is the number of items that we were looking at. Guys, do you remember when I come back here and I look at problem number 1, how many people did we have here? We had a total of 30 of them, right? So I'm going to come back over here, guys. My N is going to be the number 30, right? So look, I'm just going to fill in the rest of the blanks. Times sigma, which we said was 7.9, divided by the square root of 30. You know what? I'm going to take away the parentheses because I want to show you how you're going to do this on your calculator. Okay, so guys, on your calculator, what I want you all to do for me, please, is clear it out. I'm going to type in 1.96 times, what's the next number I have on top? 7.9. And then I'm going to hit, well, I'm going to do it like this. I'm just going to hit equals, and then I'll go divided by the square root of, what number was it again? 30, right? Okay. And I'm going to hit equals. And guys, I'm going to go ahead and round this to, oh, I don't know. Let's go ahead and go to 2 decimal places. My question to you, would I write 2.82 or 2.83? 83, okay. And now we're going to figure out what that means. 2.83. Okay, so we were able to find our ZC. I hope the way we found our ZC made sense, right? And then we sort of used this whole formula here, right? And the whole point is like, okay, what did I just do? What does that 2.83 mean? The 2.83, guys, is the margin of error, okay? So look at the confidence level we're looking at. The confidence level we were looking at, let's see if I can get a better one here. Okay, the confidence level we're looking at was what percent confidence? 95% confidence, right? Do you remember from problem number 1 what the average was when we found our average? When we did our second bars, remember we got our X bar? What number did we come up with? 28.9, okay. So what we're saying here is that with that 95% confidence level, the average number of hours worked would have been 28.9? Okay. Plus or minus 2.83 hours, because when they're working, they're measuring it in the sense of number of hours, right? So we just figured out with a 95% confidence level, we could say the average employee works 28.9 or whatever number it was, I already forgot what it was, hours, plus or minus 2.83 hours. That's my error. I'm going to be off either by, I'm too high or I'm too low by 2.83 hours, okay? So I'll tell you what, let's do the same thing for problem number 3. Let's see if we can't figure this out. Okay. And I'm going to try to kind of show you guys the process and how I'm going to do this, okay? So number 3 says, a survey of a random sample of 1,000 smartphone owners. Okay, guys, before I do anything else, How many people are we looking at here? That's going to be my N number, okay? Found that the mean daily time spent communicating on a smartphone was 131.4 minutes. Guys, we're looking at the mean, right? But because this is only for 1,000 people, this is going to be my X bar, okay? My X bar, my average here was 131.4. And I want to write it like this, minutes, so that I understand what does that 131.4 tell me. It says, from previous studies, it is assumed that the population standard deviation is 21.2 minutes. Okay, so my sigma is going to be at 21.2 minutes, okay? Now, look at the next part. Oops. The next part says for what kind of a confidence level? 90% confidence level. What would the margin of error for the population mean daily time spent on communicating on a smartphone? Okay, so guys, the first thing I'm going to do, I'm going to move over a little bit to the side here, okay? I'm going to draw my picture just like we've been drawing it before. I'm going to go like this. Look. Okay, we're going to find those critical values. One of them is going to be negative, right? The other one will be positive. What is the area that we want the middle to be? 90%, right? So guys, think about it this way. If 90% is going to be in the middle, how much would be on the sides? 5%? So isn't that 0.05 here? And 0.05 there, right? Okay, so guys, remember, the reason why I'm using this number here is because my calculator, whichever calculator I have, always tells me, just like the way the table does, it always tells me the area of which way? To the left, right? Okay, so what's the area to the left here? 0.05, right? So I'm going to turn on my calculator. Okay, clear it out. Oops, turn it on. Clear it out. We're going to go second vars. We're going to go inverse norm. And let's see. I'm going to type in what, 0.05? Okay. And let's see. Guys, would you say 1.64 or 1.65? 64. Okay, so look. The negative one is a negative 1.64, and the positive one is a positive 1.64, okay? So now, I'm going to come back over here. We found our ZC to be a positive 1.64. All right, now I'm going to find my margin of error. So my margin of error, guys, I'm just going to copy the formula that I had before, which was this piece right here. I'm going to copy it down here just so that I have it. So it's going to be ZC times what, sigma? Square root of n? Okay. So what do we get our ZC to be right now? 1.64. Okay. Times, what was our sigma in this case? 21.2? And we're going to divide all that by the square root of what number? There we go. Okay. So again, let me grab my calculator here. Let me clear that out. 1.64, okay, times, what is it, 21.2? Okay, equals. Then I'm going to divide it by the square root of, we said 1,000? Okay. And 1.10? And guys, remember, because we're talking about how much time? Wasn't our time in what? In minutes, right? So there we go. We got it. So far, so good? Calculation is not too difficult to do? We're all on the same página? Okay. We're going to do 2 sections today. Yes, ma'am. Uh-huh. Yes, ma'am. Okay, so I want you to look at right here. See how this has the ZC? Remember, every time we're doing this, we're going to find 2 values. Oops. Yeah, let me see if I can get rid of that. Here we go. One of them is going to be the negative one, and one's going to be the positive one, right? We're always going to be using the one that's positive. Now, guys, let me ask you a question. Are you all good on how we're finding the 1.96 or the 1.64? You're good on how we're finding that? Okay. So far, so good, everybody? Okay. So I want to point something out. What was our confidence level here? 95, right? And what was our confidence level here? 90? Okay. If you go back to the first page, and I want you to look at something here. With a 95% confidence level, did we end up with 1.96? Right? Guys, is that the same number that we got right there at 95%? 1.96, right? Okay. And then at, what was the other one? 90%, what number did we use? We used 1.64? What number did they have there? 1.64, what? 5? Okay, maybe I should have put a 5, but we ended up going to 2 values just because they typically run that way. So I want to point something out. You don't have to do that little thing every time. There are some standard ones that you can always use, okay? And they're here in the notes, obviously, they're on the first page. But my point is, do you see how the ones we had here were 80, 90, 95, 99, right? Do you remember when we did, let me see, let me kind of pull this up together. When we did this problem here, and I'm just going to erase some of this mess because it gets a little messy here. What was our confidence level in this case? 92. Do we have a 92 there? No. So we went ahead and drew the picture, right? So my point is that if you're using one of those standard ones, like 80, 90, 95, 99, you can always use the ZC values already there given to you, okay? So you don't have to do the picture every time. But if it said something like, say, instead of an 80%, say it wanted an 85, okay, then draw your picture and you can figure them out, right? I just wanted you all to have an understanding of how we come up with those numbers, okay? So, very good. Glad you're asking the good questions, okay? So, let's take a look at the next problem here, guys. I want to say it's at the top of your next page. And it says, use the values on the number line to find the sampling error. Okay, so guys, what we're looking here, we're looking for the sampling error. Remember what this is telling me? This is telling me the sample mean, okay? So we would know that the sample mean is 3.8. We were able to find out that the population mean is 4.19. What the error is, guys, the error is how far is it from that point there to that point there. How would I find that error? Subtract those two numbers, okay? Let me get my calculator. And let's go 4.19 minus, what do we say, 3.8? And the distance there is what, 0.39? Anybody else coming up with the same numbers? Yeah, we're good? Read a question, or you just, okay, just checking with you. Okay, so the error here was what, 0.39? Boom, there's our error, okay? All right. So guys, let's take a look at number 4. We're going to talk about now about how to find these confidence intervals for a population mean, okay? So, I'm going to come here and it says right here, the confidence interval for the population mean mu is x bar minus the error, and x bar is supposed to be plus on the other side. Sorry about that. There should be a plus right here. Okay. There we go. Okay. It says the probability that the confidence interval mu contains C, assuming that the estimation process is repeated a large number of times. Okay. So let's take a look here. It says construct a 95% confidence interval for the mean number of hours worked by a grocery store employees from problem number 1. Interpret your results. Okay, so first thing I'm going to do, what's our confidence interval supposed to be? 95%. Okay, guys, let me ask you a question. If our confidence level is going to be 0.95, do we already have a ZC value for 0.95? Okay, so if I were to kind of scroll back down, right, oops, here we go. At 95%, what's our ZC value going to be? 1.96. Okay, so I'm going to come back over here. I'm going to say, okay, our ZC value is going to be 1.96. In this case, I don't want to have to draw that picture every time, so if I can use those numbers, I'll use those numbers, okay? Now, let's see if we can find our error. So the formula for the error is going to be ZC times our sigma divided by the square root of n. Okay? So we already know that our ZC number is going to be 1.96. Okay, let's see if we have our sigma. It says we're coming back to problem number 1. So I'm going to scroll over here to problem number 1. But I want you to notice in problem number 2, look what problem number 2 said. Use the data in problem number 1, right? 95% confidence interval. Didn't it give us the standard deviation already? Wasn't it 7.9? Okay, so I'm going to come back over here. We said that number was 7.9, okay, divided by, we're going to do the square root of, do y'all remember how many employees we were looking at? We're looking at 30. Guys, let me ask you a question. Did we already do this in problem number 2? Right? Didn't we do that already? If you look, don't I have the same numbers there? 1.96 times 7.9 divided by square root of 30. What was our answer when we did it? 2.83. Okay, so we don't actually have to go through a lot of the calculations because we did it already. 2.83. Okay, remember we said that was in what, hours? Okay. Now, the part that we're going to do that's new for us, okay, is we're going to write out what we call the confidence interval. This is our confidence interval, okay? So guys, I'm going to write this little formula right here. I'm going to put x, oops, sorry. I'm going to put x bar minus e, okay? X bar plus e, okay? So from problem number 1, when we put all those numbers into our calculator, do you remember what the mean was when we did it the first time? It was what number? 28.9, right? Wasn't that our average when we did this? Okay. So guys, I'm going to come back over here and I'm going to say, look, right here under my x bar, I'm going to write 28.9 minus, what was our e in this case? We just found the e. We had found it earlier too. 2 point what number? 2.83, right? That was our e. That was our margin of error. 2.83, okay. Is less than mu, which is less than x bar again, which was 28.9, plus our e, which was 2.83. Okay, so guys, I'm going to take my calculator. I'm going to show you what I'm basically writing here in the middle, because I want to make sure we understand what we're doing. So let me turn this guy on. Let me clear it out. So I'm going to go 28.9 minus 2.83. And are you coming up with 26.07? Okay, so 26.07. Okay, and then 28.9 plus 2.83 is 31.73. Okay. That's my answer. Guys, sometimes they'll write it like this. Okay, and I'm going to explain what we just found right now, okay? Do you remember what we said I'm going to write it down here so we don't forget. Do you remember what we said our x bar was? What was our x bar? What was the average that we found when we did our calculation in problem number 1? 28.9, right? And that was in hours, right? That was our average, okay? And then didn't we find our error to be, what, 28.3? So what we're saying here is that the population average, if we were to take all the grocery store employees in Hidalgo County, we would say that we're going to be 95% confident that the average number of hours of all the employees is going to be anywhere between, what did it do that? There we go. Between 26.07 hours and what? 31.73. That's our range, right? Because what would we do? Remember, since the error was at 2.83, we said it's going to be 2.83 plus or minus, right? So we did the one where we did the minus. We did the one where we did the plus. Does that make sense so far? We're okay? All right. So let's see if we can do the same thing for numero 5. That's right. Well, yeah, but remember, that's how we've done every single problem on every test, right? But so if you go back and you think about the first test, let me pull up because I still got it right here. Yes, right here. And when we took our first test, let me see if I can get here. Okay, so guys, if you remember when you did the first test and you came up with a frequency table here, and then I said make your histogram. If you got this question wrong, but you based your answer here based on what you did here, I gave you the full credit anyway, right? So, because I'm trying to determine, do you know how to do this from that one, right? And I would do the same thing, right, with something like this, right? So if you came up with, like I want to say, I know Fred was saying earlier when he entered his numbers in, he came up with like 28.3, right? But if that was the only mistake he made, that just tells me that when he entered his numbers in, he put the wrong number. But if he still came up with 2.83, and so his numbers would just be off a little bit, but he's using that, his 28.3 and his 2.83, he's still doing the process correctly, right? So don't worry so much about, well, if I make this mistake, then everything else is wrong. It is, but are you doing the process correctly, right? That's what I'm looking for. That's right. That's right. So even if you came up with here, I'm going to make this up. Suppose you came up with 14, but you still added or subtracted 2.83, then I would grade this part correctly. I would only take off points for the first one you did. Does that make sense? All right, so guys, let's take a look at number 5. It says construct a 90% confidence interval for the mean daily time spent communicating on cell phones from problem number 3. So I'm going to come back to problem number 3. Let me see if I can find it. Here we go. Okay, so did we know what our X bar was in problem number 3? 131.4. Okay, so I'm going to come back over here. I'm going to write down a couple of things. So we knew that our X bar here was 131.4, right? And did we already find the error on number 3? What was our error on number 3? 1.10, right? Okay, so I'm going to come back over here, and I'm going to say our error was, y'all told me earlier, it was 1.10, right? So guys, when I'm going to do my interval, right, I'm going to go like this. I'm going to say X bar minus the error, and X bar, what, plus the error? Okay, so remember, we said our X bar was, what, 131.4. We're going to subtract 1.10. And then we're going to take 131.4 and we're going to add 1.10. Okay. So let me get my calculator again. Let me move it this way so everybody can see. Okay, 131.4 minus 1.10 or 1.1, because that's essence what it is. 130.3. So 130.3. Okay. And 131.4 plus 1.10, you said you came up with how much? 132.5, right? Yeah, 132.5. So like this, right? From 130.3 to 132.5, right? So far, so good? We're good? Seems I'm trying to make it, I'm trying to give it to you as directly as possible, right? Super direct. Okay. So, guys, there is a way we can do this using our calculator also, right? Right? A little bit quicker, right? A little bit quicker, but, okay, so let's take a look here. Look, it says use technology to construct a 99% confidence interval for the mean daily time spent communicating on cell phones from problem number 3, interpret your results. Okay, so let's do this. All right. do you remember what the X bar was from number 3? 131.4, right? Okay, do you remember what the standard deviation was from problem number 3? Go back to problem number 3. Yeah, but hold on, what's the standard deviation here? 21.2, good. So look, I'm gonna go right here, 21.2, okay? And the n is the number of people we're looking at. How many people were we looking at? 1,000, okay? And then our confidence level. What's the confidence level that we want here, guys? Okay, so guys, oops. Okay, so as a decimal, do y'all agree with me it would be 0.99? Okay, so guys, what I'm gonna do, I'm gonna grab my calculator right here, move it over a little bit, I'm gonna clear it out. Okay, I'm gonna go to stat, and I'm gonna go over to the right to where I have tests, okay? And we're gonna go to the Z interval test. So on my calculator, it's number 7. I don't know exactly where it is on yours. Okay, so we're gonna go like this. Clear, we're gonna go stat. Okay, we're good so far? Okay, guys, scroll over till you hit tests. Okay. And then do you see the one right here that says Z interval? That's the one we're gonna use, okay? We're gonna go to Z interval. Right here, enter that in. Okay, if you see how it has data and it has stats, we're gonna go to the one that has stats. Okay, and I'm gonna hit enter. Okay, so my sigma, let me see if I can do it here. What was our sigma in this problem? So I'm gonna type in 21.2, okay. Okay, what was our X bar in this problem? 131.4, okay. What was our N number? How many people were we looking at? 1,000, right? For whatever reason, I wrote 100. Boom. Let's fix that. Okay, come back. And it's 1,000. 1, 2, 3. Okay. Confidence level. What was our confidence level? 0.99. So we're going to go 0.99. We got 99 problems. And guys, go down to calculate and then hit enter. Give it a minute. Okay. And there it is. So my interval. Well, see how it's getting to me in parentheses already? So the first one is what? 129.67? Comma, what's the second one? What's the second number? 133.13? Boom. There you go. Right? Yes. Yeah, so we're going to go like this. So look, guys, let's follow along, right? I'm going to turn it on. I'm going to go to stat, right? I'm going to go to tests. And I'm going to scroll down till I hit Z interval, okay? Okay, and do you see how we have two? One of them says data, one says stats. You're going to one that goes says stats and hit enter. Okay, right here, my sigma. So guys, I want you to notice something. I'm glad Myra asked me this question. Before I'm even looking at my calculator, notice the first thing that I wrote. I wrote these things here, right? Because I have to know what each of those little symbols stands for, right? So when I come back over here, look at the first one we have, the sigma. What was our sigma? 21.2, right? So we went 21.2, okay? And look, here's my X bar. What was my X bar? 131.4, right? And then our N, wasn't our N 1,000? And then our confidence level, guys, you see what I have right here? 0.99, right? So I can't just write 99, I gotta put 0.99. And then I'm gonna go to calculate. Myra, before I go on, are we good? Okay, anybody else? We're all good here? Guys, I'm gonna hit enter, and there comes my answers, right? We don't need the ZC for this problem, because so what my calculator is doing, it's sort of bypassing that part for me, right? What did it say? It'll give you something different? And so you hit enter twice, is that what you just saying you did? Okay, guys, let me ask you a question. Do we know what our error is here? Did we find the error? So remember what Myra was asking me right now? Myra was asking about, okay, what about the ZC? Okay, so I want you to notice something here. Guys, do you see how right here, here's my formula for my error, okay? Remember what the error was? In this particular problem, the error was what? 1.10, right? Okay, do you remember how we did the problem? Let me see if I can find it. Like here, like number 5. See how we found the error. We already found the error to be 1.10, right? And we came directly to this part here. Okay, isn't that kind of what we came up with right here? Didn't we come up with this answer kind of in one step, right? Because we used the calculator. Okay, do you remember how we came up with the 130.3 and the 132.5? Do you remember how we came up with those two numbers? By adding and subtracting, right? But we also knew that our mean was what number? Was 131.4, right? Okay. So what I want to point out, let me see, and I think we might have a problem like that here. Yeah, actually, well, we can do it here. So I want to show you that how would you find the error from this part? Subtracting, right? What would you do? You would take what numbers? Okay, so you would take your calculator and you'd say, let's take 133 point, what was it, 13? Okay, 0.13, and you would minus what number? Well, hold on, wait. So I want you to come back. I want you to, hold on, wait. I want y'all would go too fast. Think about it, think about this problem, the one we did a little while ago. Okay, didn't we already have our 131.4? Okay, remember what the 1.10 was? Wasn't 1.10 the what? What does that E stand for? The error. Wasn't the 1.10 the error? So when we did this problem right here, didn't we take 131.4 minus 1.10 and 131.4 plus 1.10, right? And that's how we came up with those two numbers. So how would we do it from here? How would we find the error from this part? Okay, we're going to minus, right? So look, I'm going to take my calculator again. 133.13. What number am I going to subtract? 131.4, ¿verdad? Because that's going to tell me what did I have to add to 131.4 to give me that bigger piece. Does that make sense? So we do that. What would our error have been? 1.73. Does that make sense how we're able to do that? Because remember what we're saying, we already know that the average is 131.4, right? We know that's the number in the middle. Well, we took this number and we added something to it to get this number here. So what are we doing? We're going to take this number and we're going to subtract our 131.4, and that'll tell us what that error was. Okay.
Do we need that for the answer?
Well, we don't necessarily need that for the answer, but remember, in your homework, there's going to be certain problems, Myra, that are going to just ask you for the error, right? So if it asks you for the error, then I have to go through and using the ZC times the sigma over the square root of n, right? I have to basically do it like the way we did this part right here. But if it's asked me to do just to come up with a confidence interval, then I can just use that little Z interval test that we did right now. Okay. So I want you all to do me another flavor. Let's take a look at the next problem here. Let's see if we can figure this thing out. Let's see. I'm going to grab my pen. Okay, so it says a college admissions director wishes to estimate the mean age of all students currently enrolled. In a random sample of 20 students, the mean age is found to be 22.9. So guys, the first thing I'm going to do, I'm going to go like this. X bar is 22.9, okay? From past studies, the standard deviation is known to be 1.5 years. Isn't that our sigma? 1.5, okay? And it says construct a, what, 90% confidence interval? So how would I write 90% as a decimal, guys? 0.90, okay? One more piece of information I need to know. The n. How many people are we looking at? Very good. We're looking at 20. Okay, so guys, since all we're trying to find is that confidence interval for the population mean age, I'm going to grab my calculator again. I'm going to clear this thing out. And I'm going to go to stats, right? I'm going to go to tests. I'm going to go to my Z interval test. I'm going to enter that in, okay? I'm still going to use my stats. So guys, a lot of times when you do this, your calculator might be here on data. You want to click it over to stats, hit enter. Let's see, okay. What is our standard deviation here? 1.5, excellent. Okay. Enter. Okay, what is our X bar? 22.9, okay, boom. Okay, N is going to be 20. Excellent. Thank you, sir. What about our confidence level? 0.90, right? And then, guys, I'm going to go to calculate. I'm going to hit enter. And I'm going to write down exactly what we have. 22.38. Oops. Or, yeah, 22.348. 2, what's the other number? 23.452. So again, guys, all we would be saying here is that with a 90% confidence level, we could say that the population mean age is going to be between 22.348 years and 23.452 years. Right? So a lot of times when we sort of use that phrase in general, like, man, I'm 99% sure that I did that, we're just kind of, right, we're just, I'm pretty sure, right? Are you really 99% sure? Well,
To get there, you just subtract the one to the right and the 22.9.
that's right. So if I wanted to find my error, that's very good. So guys, Isaac's saying, look, if we wanted to actually find the error here, one way we could do it is we could say, look, let's take 23.452 and subtract what number? 22.9, right? So 23.452 minus 22.9. And so our error would be 0.552, right? That would have been the error there. Okay. All right, so guys, just two more parts and then we'll take a break. So let's take a look at the next part here. It says, use the confidence interval to find the margin of error and the sample mean. Okay, so guys, I'm glad that we just did those problems right now. Remember how we came up with the error in this problem? We took what number? We took 23.452 and we subtracted what number? 22.9, right? And that's how we're able to find our error. Guys, let me ask you a question. In this problem here, do we know what the mean is? Do we know the average? Or do we just know the interval? We just know the interval. Okay, so I'm going to show you the easy breezy cover go way of finding the sample mean. Okay. We're going to be kind of working backwards. So I want you to think about this for a minute, guys. Okay. So my sample mean is going to be here, right? And the way we're coming up with this number and this number here, so this number in this case was 0.422, and in this case, this number was 0.580. So there's two things we want to find here. Number one, we want to find this number, and then number two, we want to find what that error is. Okay, guys, let me ask you a question. Just the way I drew the picture, would you agree with me that this number is right in the middle between those two? Okay, so the way I'm going to do this, the way I'm going to find the middle is I'm going to take my calculator, move it over here to the side. I'm going to take those two numbers, guys, I'm going to add them up. So 0.522 plus, or 588, I'm sorry, 80 plus 0.422, okay, I'm getting that, and then we're going to divide it by 2 so we can find the number right in the middle. 0.501, okay, so this number here is 0.501. Now we know what the mean is, right? So now how would we find the error? We just did this a little while ago. How would we find the error now? Anybody know? We'd subtract, right? Wouldn't we take what number first? 580 minus 0.501. You got it. Take it away. 0.079. Okay, 0.079. And X bar is 0.501. Does that make sense how we're able to do that? We're good so far? Yes, ma'am. Because that's telling me the distance between here and there, right? So far, so good? So guys, I incorporated some of these problems. I don't know if you can tell or not by just the way the font is. And all I did, guys, I took them directly from my math lab, added them in here. So when you're doing your homework, you're going to see problems very similar to these, okay? All right. So I got one last problem here out of 6.1. And it says, as the level of confidence increases, the confidence interval widens. As the confidence interval widens, the precision of the estimate decreases. One way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. Remember the sample size, guys? That's going to be my n, okay? But how large of a sample size is needed to guarantee a certain level of confidence for a given maximum error of estimate? Okay, so we got a little formula right here. Okay, and it says given a C confidence level and a margin of error E, the minimum sample size n needed to estimate the population mean mu is, and they give me a little formula here. Okay, and it says if sigma is unknown, you can estimate it using S, which is our sample standard deviation, provided you have a preliminary sample with at least 30 members. All right, let's take a look here. It says number 8. The researcher for problem number 1 wants to know the number of employees he must include in a sample to be 95% confident that the sample mean is within 2 hours of the population mean. Okay, so guys, the first thing I'm going to do, I'm going to copy down the formula that I have here. N equals, and look what it tells me, ZC times sigma divided by the number E, okay, all being squared. Okay. So, first thing we're going to do, let's see if we know a couple of pieces of information. We want to find ZC, we want to find sigma, and we want to find what that letter E is going to be. Okay. So, let me ask you a question. If I look at 95% confident, and I scroll back all the way to my page 1 where we were, do we have that one already? Okay, so what's our ZC for 95%? 1.96, right? It is right there, right? It's right there. So let's come back over here. And that's going to be my ZC. That's going to be the number 1.96. Okay, there's the first number. For problem number 1, guys, did we know what the sigma was? I want to say it gave us that information actually in problem number 2. If you look at problem number 2, 7.9, right? So let me just go like this so I can clear this mess right here. There we go, there we go. And it says standard deviation is 7.9. Okay, so I'm going to scroll back to where we were. 7.9. Okay. There's that piece right there. Okay. Now, the only other piece we need is the letter E. So I want you to notice what it says here. The sample mean, if it says within 2 hours, that's going to tell me my E. My E is going to be the number 2. Okay, because I want it to be within 2 hours of the population mean. So guys, all I'm going to do now, I'm just going to come back and I'm going to plug and chug. What was our ZC in this case? 1.96. Good. Times, what was our sigma in this case? 7.9, okay. And what was our E in this case? 2. Now this number here, guys, is going to be squared. So notice the way it's written. So on your calculator, the first thing I want you all to do for me, please, is let's type in 1.96. 1.96 times what, 7.9? Equals, I'm coming up with that. Then I'm going to divide it by what number? 2. Okay. Guys, once I come up with that number, I'm going to square it. So on your calculator, you can probably hit second. And then the little x squared. Not second, sorry. Just the little square, and it should square the answer. 59 point, all that stuff. So 59.94, you said? Okay. Guys, but remember what n is. N is going to be the number of people we're looking at. Can we look at 59.94 people? How many people would we have to look at? We'd have to look at 60. Boom. And there you go. That's it. Okay, so on my calculator, what I did was, let me clear it out. I'm going to go 1.96, right, times 7.9 equals, and then I divide it by 2 equals, and then from here, do you see you have the little x squared button? Just hit the little x squared button. It should square the answer for you, and then hit enter, and I came up with a 59.938 and a whole bunch of other change. Did that work? Yeah? Everybody, we're good, guys? And then we just said, well, we can't really look at 59.94 people, so we got to look at 60 of them, right? Yeah, it should tell you rounded to the nearest. And think about it this way. Remember, when we're looking at the sample size, it always has to be like a positive integer, right? It's like, how many watermelons am I looking at? I couldn't look at 59.94. Well, either I look at the watermelon or I don't. All right.